Iran earthquake. No, the magnitude 5.1 earthquake which struck Iran yesterday on June 20, 2025 was not a nuclear weapons test or related massive explosion. I know there are a lot of fears running high involving the ongoing conflict between Iran and Israel, so I want to alleviate some of those concerns via my expertise as a geologist. I am specifically making this video after receiving more than a dozen emails and messages asking about this very subject, and I want to remind everyone to please behave in the comments as this is not a geopolitics video but rather a science video. For reference, the earthquake in question struck at 9:19 p.m. local time in the desert of north-central Iran at a spot 101 miles or 163 kilometers east-southeast of the nation's capital of Tehran. The first and most obvious piece of evidence against this quake having a human-made explosion moment tensor origin relates to a diagram known as a moment tensor, which is a top-down view that measures the relative motion of a fault line, where the region shaded in white moves towards the region shaded in blue. During an explosion, material expands outwards in all directions, resulting in a moment tensor that is either completely solid blue or almost entirely solid blue. We saw this exact moment tensor appear during North Korea's September 3, 2017 underground nuclear test, which had a yield of around 250 kilotons or 250,000 tons of TNT. Remember, the reason why nuclear weapons explosions show up as earthquakes on seismometers is that anything that causes sudden motions of rock releases seismic waves, and these waves can subsequently be detected. For comparison, this is what the moment tensor from the June 20, 2025 earthquake that struck Iran looks like, showing a completely different motion than an expected nuclear explosion. If we compare this moment tensor to moment tensors associated with four of the most common fault line types, we get a perfect match with a normal fault origin. Supporting this assertion is the fact that the adjacent Alborz Mountains and its surroundings contain numerous normal faults that strike from southwest to northeast which accommodate highly localized extension despite the overall broader compressional nature of the area's geology at the present. Earthquake depth. The second piece of evidence against a nuclear weapons origin relates to the earthquake epicenter's depth. Almost all nuclear tests which have occurred have resulted in epicenters being registered of 0 km depth, essentially indicating an explosion on the surface or more commonly not too far below ground. In contrast, Iran's latest earthquake had an epicenter at 10 km depth. A third piece of evidence for a purely waveform analysis tectonic origin relates to the exact waveform generated by Iran's magnitude 5.1 earthquake. When an earthquake occurs, two types of seismic waves are generated, an S wave and a P wave. The P wave moves faster and causes minimal damage while the S wave moves more slowly and causes more severe earthquake damage. For tectonic earthquakes, the S wave has a notably higher maximum amplitude than the P wave when it arrives at a seismic station. And this is exactly what was observed for the 5.1 Iran earthquake, an S wave stronger than its P wave counterpart. If this Iran earthquake was to have instead originated from a nuclear weapons explosion, the relationship would have been the opposite, with the highest amplitude waveform being from the P wave. Final analysis. So, once again, this earthquake did not originate from a nuclear test. Only if an earthquake's moment tensor is a solid dark color does it potentially have an explosive human-caused origin. As a final note, I would like to thank my new patron Z Brackenberry